So there are many conic sections, and we've looked at a couple of them already. So let's review the conic sections that we have looked at. The first one is a circle. So recall that a circle is the set of all points, x and y, such that each point is equidistant from a given center. So here's the given point, that's the center. Every point is a distance r, right, from the center. We call that the radius. We've also looked at parabolas. Parabolas we defined as the set of all points, x, y, that are equidistant from a given point. Okay, that's the focus, and a line called the directrix. So these two distances, the distance from our point back to the focus and back to the directrix, those two distances are equal. And then the last thing that we have looked at already for conic sections is ellipses. Ellipses, we said, were the set of all points such that the sum of the distances between two fixed points, right, those are the foci, is a constant. So we're adding the distances, d1 plus d2, and we're saying that those equal the constant value for any point on the ellipse. And the key word for this definition is sum. We're summing all of the distances to the two fixed points. So today we're going to be looking at hyperbolas. And hyperbolas are related to ellipses. So we want to sort of keep this definition in our mind. The set of all points such that the sum of the distances is a constant. So what is a hyperbola? A hyperbola is the set of all points such that the distance, the difference of the distances, is a constant. So ellipses were the sum of the distances. Hyperbola is the difference of the distances. So what does a hyperbola look like? Well, to start with, a hyperbola is a slice through a double cone, right? Just like all conic sections. In this case, if we slice straight down, we get two mirror image parabolas. And we've already graphed hyperbolas. We graphed hyperbolas when we did rational functions. So if you remember when we graphed y equals 1 over x, that's a hyperbola. Okay, it's two symmetric parabolas, right? Mirror images of each other. Okay, we're going to look at a couple of the basic parts of parabolas. So first of all, we have the foci. So F1 and F2. Right? And then right behind the foci, we have the vertices. Okay. And if you look at the line that passes right in between the foci and the vertices, right, remember those are always on the same axis, we call that the transverse axis. Okay. And then right in between the two foci and the two vertices, so smack dab in the middle of the transverse axis, is the center. Okay, so we've got the center of our hyperbola. Okay, now these boxes, this pink box and these green dashed lines, they really don't have anything to do with the graph of the hyperbola. They're sort of imaginary lines that help us to see the shape of it or the direction of it. So these values right here, of course, c is the distance out to the foci, but this distance this way going up and down, this is called the conjugate axis. Okay. And we create these two, okay, by finding values from our equation. So remember that in an ellipse, A and B were sort of like the distance up and the distance over, or how tall and wide the ellipse was. This is going to give us how tall and wide to make this pink box. Now, do we need this pink box? Not really. It's only there as a guide. The job of the pink box in this case is to help us find these green dashed lines. These guys are called asymptotes. And once we have the asymptotes of a hyperbola drawn in, that helps us to know where is this parabolic curve tending toward. Remember, asymptotes are sort of like guidelines. So we use the pink box to create the asymptotes, and then once we have the asymptotes, then we use the asymptotes to help us guide where to draw these curves. So I pass through the vertex and I make the curve go up, and then it tends toward these asymptotes. All right, more specifically, let's look at the two types of hyperbolas that we're going to be talking about. We've got right and left, right, or horizontal orientation hyperbolas, and the standard form is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. And this equation, I hope you recognize, is very similar to ellipses. The only difference is this is a minus instead of a plus, because hyperbolas are differences instead of sums. So the center of the sky is HK. The foci are out here. Right. This distance from the center to the foci is the focal length, c. So that means that the foci have coordinates h plus and minus c. So we add and subtract the focal length to the x value and k. The vertices are on the same axis, so v1 and v2. And this distance here is the distance from the center out to the vertice, and that's a. So this is h plus and minus a, same k value, same y value k. And then the equation of this transverse axis right here is going to be y equals k, and it should be parallel to the x-axis. And then the equation that we're going to use to find the focal length is a squared plus b squared equals c squared. Okay, let's take a look at vertical hyperbolas. Instead of starting with x, they're going to start with y. So y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. So again, subtract because it's a hyperbola and we use the difference. And you'll notice this time the y part comes first, the completed quantity square value for y comes first in the equation, and so it's going to go up and down. So we still have the same center, hk. This time the foci are up and down. So that means that to find the coordinates of the foci, we're going to have the same value for x, but we're going to take the y value and add and subtract c, the focal length. Then the distance out to the vertices, there's v1 and there's v2. This is going to be a. So to find the vertices, it's going to have the same x value, but we're going to go up and down from k with our a value. The equation of the transverse axis here is going to be x equals h, and it should be parallel to the y-axis. And then again, to find our focal length c, we're going to do a squared plus b squared equals c squared. You can pause the video if you need another minute to write this down. Okay, let's take a look at a couple of examples here. Find the coordinates of the center, the foci, the vertices, and the asymptotes, and then graph. So since the y term comes first, we know this will open up and down. Up and down. Okay, y came first. Then we're going to pull out the values for h and k, and then a and b. So we know this guy has a center at -1, 2. And we know the vertices, we're going to go use our a and b values. Okay. So the next thing we want to do is we want to graph the center and put in our box. Okay, so how did we make this? Well, we plotted the value of the center. This is the point minus 1, 2. Okay, then we're going to go 6 spaces to the right and left for x, okay, from here. And we're going to go 8 spaces up and down because of here. That helps make the box. Once you have your box, you can draw in your asymptotes. Okay. And once you have your asymptotes, this is going to guide you to be able to make your hyperbola. So I'm going to put my pencil on the vertices, and I'm going to go out toward the asymptotes. Out toward the asymptotes. So one on the bottom and one on the top. Okay, you can pause if you need to write this down. All right, now take a look. I want you guys to try these problems. So go ahead and pause the video and work on problems 1 through 4 on your worksheets. And if you have questions, you can take a look at the key when you're finished. The substitute will have that. Okay, so we want to look at how to put equations in standard form so that we can find all that good information like the center and the distance for the transverse axis. And we're not going to be able to do that until we take these kinds of equations and we kind of play around with them a little bit. In this case, we're going to need to, sorry about that. In this case, we're going to need to complete the square a couple times. And it's the same process that we looked at with ellipses. So let's start by splitting things into x and y values. And we'll factor out the leading coefficient so that we can complete the square. So I've completed the square twice. Okay, notice that here I haven't just added 25, I've actually added 25 times 25, right, because I'm distributing. And so I add that to the other side. Okay, and then I'm going to factor these perfect squares. And the last thing I want to do is divide both sides by 500 so that it's in my proper format. Once I have this, I should be able to go back, find A, find the center, find B, and graph my center, my box, my asymptotes, and then draw in my parabolic branches. Okay, I want you to try doing problems 5 and 6. Do it the same way that we just did in the example together. Go ahead and pause the video, work on these problems, and then as you finish, the sub can come around and you can check your answers with the key. Okay, let's look at our next example. Find the equation of a hyperbola with foci 5, 2, negative 1, 2, whose transverse axis is 4 units long. For these problems, I recommend that you graph the information. In this case, we know that right in the middle between the two foci is the center. So I use the midpoint formula to find the center. If you don't know the midpoint formula off the top of your head, of course you can just graph the two foci and then you'll find that this is the center. Okay, so there's my center. I need to now find the transverse axis is 4 units long, and that means that it's only 2 spaces out to get to one of the vertices, and it's only 2 spaces out to get to the other vertice, and that means A has a value of 2, and therefore A squared has a value of 4. Okay, I know A squared has a value of 4. I also can tell from my graph that C, the focal length, is 3. So now if I use A squared plus B squared equals C squared, I'm going to be able to solve for B squared, which is 5. Once you know A, B, you can plug, and H and K, you can plug everything into the standard equation. So notice that I plugged in H and K, and I plugged in A squared and B squared. So I'm going to have you try problems 9 through 12. Go ahead and pause the video, and then as you finish working on these problems, you can check the answer with the sub. I will have the sub write the homework on the board for you, and then you can spend the remainder of the period working on homework and starting your project for Friday.